right. All right. Well, thanks everybody for having me talk today. I really appreciate it. I've been doing a long-term research study on white-headed woodpeckers primarily, but also other cavity nesting species up in Yakama County primarily, as well as a little bit of Kittitas and some of Klickitat County. And so today I'm going to be presenting a portion of the last 20 years of my research on white-headed woodpeckers. And specifically, I'm going to be talking about the types of habitat that they select for where they locate their nests, and also how that influenced nest survival or reproductive capacity of the birds. And this was all done in managed forests, primarily in ponderosa pine. So this is not an oak species. White-headed woodpeckers are really much tied to habitat that contains just ponderosa pine in Washington. But I have seen them in the kind of transition zone between oak and pine, particularly like around the Goldendale area and also around the Cowiche area in Yakama County. So for those who have never seen a white-headed woodpecker, this is what they look like. The male is on the left. He has a little red spot on the back of his head, and the female is on the right. They are aptly named because they have a bright white head, and the rest of their body plumage is almost entirely black with just a large white wing patch. You can see on the female in the lower right, her wings a little extended there. Their range is throughout all of throughout the extreme Western North America. But you can see that their habitat is pretty disjunct. It's not a continuous occupancy of range. And the reason for that is, as I mentioned, they're tied to pine species. And up here in Washington, it's ponderosa pine because it has large seeds, which they use as a food source. But then as you get further down into Southern Oregon and down into California, you get a few more pine species with large seeded cones. And so their populations are a little bit higher in density the further south you go. So at the northern part of our range here, they are a priority habitat species with Washington Department of Fish and Wildlife. So why study white-headed woodpeckers? Well, when I started this study when I started working for the Yakama Nation in 2002, this species was brought up as a species that needed old growth ponderosa pine. And so when I started looking into this species, I could only find one study that was done in Washington. That was published in 2003. Historically, they are thought to be tied to old growth structure. And I was consistently encountering these birds in heavily managed stands when I was reviewing timber sales as part of my job. So I got to thinking, well, if these birds are here, how well are they doing in this managed habitat? Because it's not technically what the literature said that they were supposed to occupy primarily. As I mentioned, they're a species of concern in Washington. And a recent report a recent analysis that was just done with some eBird data from Cornell showed that the white-headed woodpecker in Washington has actually experienced a 20 to 30% decline in abundance since between 2007 and 2021, so over the last 15 years. That was pretty concerning for me to see that. As I mentioned, they have a very restricted range here in Washington because they're dependent primarily on pine. Okay, so our objectives were to focus on managed forests, describe their nest site characteristics, so what are these birds using for nesting, and determine how that influences their reproductive success or nest survival. And I also wanted to collect some data on parental provisioning because we really didn't know what the birds were eating in terms of insects and what they were feeding their young while they were breeding here in Washington. So these were the primary study areas for my research. The main one is up in northern Yakama and southern Kittitas County in the Weenass area. And that's currently where I'm focusing my research on now. Probably over the last 10 years, I've kind of eliminated these other areas just because they were too far to travel. But when I was looking for nests and doing the nest survival stuff, I was trying to go to areas where I knew or where people had seen white-headed woodpeckers and trying to find as many nests as I could. So you can see I did have one study area down here near Glenwood. Okay, so we searched for nests and we did the nest survival analysis from 2005 to 2010. And when we found a nest cavity, we used a device. It's actually called a treetop peeper. It was manufactured by a company in California called Sandpiper Technologies. And what this device does is it allows you to look inside tree cavities. So there is a probe that was on the end of this telescoping pole, and we would stick the probe into a nest cavity, and it had two lights and a camera that would face down into the cavity so you could see the contents of the nest cavity. And then it would display an image on a monitor that was affixed to the base of the telescoping pole. So we could look into nests that were as high as about 11 meters in height, so about 30 feet high. So here's a picture taken of the monitor showing two white-headed woodpecker nestlings recently hatched and then one unhatched egg there. So you can see we got pretty good detail of what was inside the cavities. And then this other photo here is actually an adult white-headed woodpecker that happened to be in the cavity when I checked it. And she was incubating eggs at the time. And she was not quite too happy to have this big bright light thing shining down on her and taking her picture. So using the treetop peeper, we were able to determine fate. So we could check these nests about every 2 to 3 days. We could keep monitoring them so we knew approximately when they hatched and about when they would fledge. So if the chicks disappeared before the anticipated fledging date, we assumed that nest was predated or failed somehow. So we were able to determine the reproductive output of these nests. When a nest was finished, we measured a variety of different habitat characteristics associated with that nest site within an 11.3 meter radius circle. And I won't go into what all those were and how we collected a lot of them, but they included things like cavity height, canopy cover, diameter of the nest tree, the shrub cover around the nest, things like that. We tried to characterize as much of the habitat associated with the snag or where the nest cavity was located. Then when we were finished, we tagged each tree with a numbered aluminum tag so that we could track cavity reuse by other species such as western bluebirds, northern flickers, and some other secondary cavity nesters. So for provisioning for what the adults were feeding the chicks, we used a spotting scope with a 10 power eyepiece. And we did this from 2009 to 2011, so over a 3-year period. And yep, I dressed in full camouflage, tried to make myself blend in as much as possible with the surrounding environment. And I sat between 100 and 160 feet from the nest cavity, trying to get close enough where I could see with the spotting scope what the birds were carrying back in their beaks. And I only began the observations after the adults resumed normal activity. So as I'm sure many of you are aware, animals are extremely aware of their surroundings. So regardless of how much I tried to sneak in, inevitably the birds knew I was there. So in order to get accurate representation of feeding intervals and things like that, I had to wait for the birds to settle down to kind of forget I was there. If that didn't happen within about a 30-minute period, I would abandon the observation period for that day and try to come back again on another day. And I always tried to view the cavity from the side or from a profile view, as this picture shows, so that I could try to see what the birds were carrying back to the chicks in the cavity. Okay, so we monitored the cavities for 2-hour time periods between 8 and noon. And we did this once when the nestlings were 1 to 13 days old, and again when they were 14 to 26 days old. Every time a bird came back with food, we recorded the sex of the adult, the amount of time between visits, and if fecal material was removed from the cavity, such as this bird down here in the lower right is removing some fecal material intermixed with wood chips that they excavate and put inside the cavity. Because there is no nest material for woodpeckers. They simply lay their eggs on a bed of wood chips that the birds constantly replace throughout the nesting period as they remove fecal material from the nest cavity. So I tried to determine first just if prey were large or small. So this female here returning to a nest cavity, that would be considered a small prey item because her beak is completely closed around the prey. And then this would be considered a large prey item where the beak is visibly open and you can see that there's prey material sticking outside the beak of this male returning to a nest cavity. And then I tried to determine the prey type to order, or family. So example, if they were carrying a beetle or beetle larva, that would be order Coleoptera. Okay, so getting into some results. So when do white-headed woodpeckers nest? Well, they're actually, we found out they're one of our later nesting woodpeckers. You can see here, I also did some work with hairy woodpeckers as well, and you can see that they have pretty distinct nest initiation period. So what I mean by nest initiation is the day that the first egg is laid, not the day that the cavity was started excavating. And so you can see the peak nest initiation period for hairy woodpeckers is about the end of April or first week of May. Whereas in white-headed woodpeckers, this is more towards the end of May, about the last 2 weeks of May. So very distinct nesting periods here for these two birds. And I think the later part of the nesting period for white-headed woodpeckers has to do with the prey that they're bringing back to the chicks, and I'll address that a little bit later. So for nest site characteristics, I did this study in both burned and unburned habitat. And so we've partitioned those results out here to look for differences between burned and unburned nest site characteristics. And you can see that most of the nest site characteristics did not differ between burned and unburned habitat. So the substrate DBH, the snag height, cavity height, slope, shrub cover, snag density did not differ significantly between the two habitat types. The only thing that did differ was canopy cover, which sort of makes sense because there's a lot less canopy cover in a burn than there is in unburned sites. And also live tree density was much greater in the unburned stands or the unburned nest sites than at the burned sites. But other than that, the habitat characteristics were fairly similar around nests in the two habitats. So this table here demonstrates the type of nest substrates that the birds were using. In the next couple slides, I'll explain and give examples of what these types are, but type 1 would be a completely live tree. And then you go down the scale to a type 4, which is a dead snag that is in a heavy stage of decay. So you can see that over half of our nests for white-headed woodpeckers were located in the type 4 snag. So these birds are selecting the most decayed or the most advanced decayed snags on the landscape for cavity excavation. And not surprisingly, they selected ponderosa pine the most frequently for nest sites because my study was done in ponderosa pine habitat. But they occasionally use some Douglas fir, actually a blue elderberry, which was pretty amazing. The elderberry shrub was still alive, but it had a pretty good size diameter trunk on it that they were still able to excavate a cavity, and a few aspen in there as well. But primarily, not surprisingly, these birds were nesting in ponderosa pine snags. So here's some examples of some of the different types. So right here would be an example of a type 1 nest substrate. So this is a live ponderosa pine. This was up in the Nile area just west of Yakima. And the birds actually nested right kind of in this lower section of this live pine. Now it looks like a fire had come through here, created a burn scar, which allowed some decay to set in, and that's where the birds excavated their cavities. And you can see this cavity is really close to the ground. It was only about, I think, 2.5 feet, 3 feet above the ground. So these birds are not averse to nesting close to the ground, but in doing so, it does put them in jeopardy of potential nest predation. So you can see how the bark is missing off the right-hand side around the nest cavity here. And that was actually done by a bear that was trying to get into the nest cavity. And luckily the wood was hard enough that the bird was not able to, or that the bear was not able to break through the outer layer of the tree to get into the nest cavity. So these birds were lucky and they were successful. They did fledge their chicks. This here would be an example of a type 2 nest substrate. So this was in a fire that happened just west of Yakima off of Highway 410. And this was the first year following the fire. And the birds again nested in the area with the little red box. And again, very close to the ground. So a type 1 would be a recently killed tree or a recently dead tree that still contained a lot of the needles, as you can see up above. This would be an example of a type 3 nest substrate. So a little bit more advanced decay. The top is still intact, but all the needles are gone. A lot of the small branchlets are gone. And the birds located their nest cavity just below this junction here at the top. And then these would all be examples of type 4 nest substrates, the ones that were more frequently used. So these trees or snags were all in advanced stages of decay. Most of them had busted tops, so the tops had already broken off. And you can see that they're all fairly close to the ground, especially the one in the upper right that was in a cut stump. And yes, those birds were successful. They did fledge their chicks, surprisingly. They're very capable of nesting close to the ground, but again, it does put them into jeopardy for increased risk of predation. Okay, so demographic variables. So the variables that go into influencing how many chicks basically are produced from each cavity. So they have an incubation period of about 12 days. So the first column there is the sample size. Second column there is the mean or the average. And then the third column would be the range of values. So incubation ranges between 11 and 14 days. They have an average clutch size of 4 eggs, and it ranges from 2 to 6, but it's most commonly 3 to 4. They fledged on average a number of 3 chicks from each nest. And again, that was from 1 to 4. They average about 1 unhatched egg per nesting attempt. And the reason for that is because woodpeckers begin incubating their eggs on the day before the last egg is laid. So sometimes that last egg does not hatch because once the other eggs hatch, then the adults stop incubating because they have chicks to feed and they're only intermittently brooding them. So sometimes the last egg doesn't hatch or sometimes it's unfertile. And then on average, about 1 young dies per nesting attempt. And that again is due to the fact that even if that last egg does hatch, it's usually a day or 2 later than the other siblings in the nest. So sometimes the other nestlings just outcompete that other young bird for food, especially if there's not an abundant food supply. So this would be an example of a nest cavity where the young have fledged and there was 1 egg left in the bottom of the nest cavity that didn't hatch. Okay, so for nest survival, we monitored 67 nests that had enough data to estimate survival, and we were able to use 55 of those actually in the analysis. And this was from 2005 to 2010. We used a statistical method called logistic exposure, and I won't go into all the stats involved with that. But basically, it looks at nest survival in a 2-stage process. So first, in the models, we look at temporal effects or effects of time. And then in a second set of models, we look at the habitat features associated with nest survival or the spatial variables. And we did this and at the end, we were able to calculate a period survival rate or a PSR. And that encompasses 4 days for the laying period, 12 days for incubation, and 26 days for the nestling stage. So from the time these birds lay their first egg to the time the chicks fledge, they're occupying that cavity for about 42 days. So it's a long investment of time for woodpeckers to nest, which is why a lot of times, and most frequently, when a woodpecker's nest fails, they often do not re-nest because they usually will almost always excavate a new cavity, which can take anywhere for another 1 to 2 weeks. And then to go through the whole nesting phase again, another 42 days added on to that. It's often too late in the year for these birds to re-nest. Okay, so when we looked at the first set of models for time, we found that the daily survival rate, so the probability of a nest surviving any given day during the nesting period, was the same for every day. So it didn't matter if it was early in the nesting period or late in the nesting period, the probability of survival was constant throughout the nesting period when we looked at time. So no time effects. But when we looked at the spatial variables, the most supported habitat model was shrub cover. So out of everything that we measured associated with habitat, including tree diameter, cavity height, which we thought would influence nest survival, shrub density, everything around those nests. The only thing that came out that influenced nest survival was shrub cover. So we thought that was pretty interesting. So this graph here represents those findings. So the solid line is our estimate, and then the dotted lines are the confidence intervals. So you can see that the y-axis on the left, the daily survival rate, so that's the probability of a nest surviving on a given day. You can see is pretty high when there's like no shrub cover, and then daily survival rate declines as shrub cover increases. So why would that be? Well, the period survival rate at 0% shrub cover. So the probability of a nest surviving, fledging at least one chick when there's no shrubs is 79%, so pretty high. But that drops to 66% chances of fledging at least one chick when shrub cover is 25%. And when it's 50% or greater, you're down to about less than a 50% chance of fledging a chick. So the first picture on the right, it would be an example of a white-headed woodpecker nest where there was no shrubs around there at all. The one that just popped up on the center bottom would be an example of a nest site with heavy shrub cover. So the birds in the bottom there, their first nest attempt failed. And they actually was one of the only times we documented this. The adults reused that same cavity, laid new eggs in there, and the chicks were predated almost at exactly the same time that the first nest was predated. So what we think is going on with shrub cover is that white-headed woodpeckers, because they occupy these dry forest ponderosa pine, they are used to being in habitat that's affected by fires, or frequent fires. So historically, fires in ponderosa pine habitat happen about every 15 to 25 years. So it repeatedly removed the shrub cover. So because these birds require well-decayed snags for nesting, which are often short, they're nesting close to the ground. And when there's a lot of shrub cover, we think that predators have an easier time accessing the nest snag and getting into the cavity before the adults detect them. And so some of the predators that affect these nests are gopher snakes, weasels, Douglas squirrels, yellow pine chipmunks. So you can imagine that all those are terrestrial, and if they're trying to access the nest cavity and they're doing it under shrub cover, they can usually get right to the snag and up to the cavity before the adults can detect them. And the adults are actually pretty good at defending the nest sites, but if they can't get to the predators fast enough, or the predators get to the cavity before they're detected, then there's an increased chance of failure. So this is why I'm all for doing prescribed burning, especially in white-headed woodpecker habitat, because it helps to control that shrub cover, and we can directly influence nest survival by doing that. And so overall egg success, so out of all the eggs they laid, only about 50% result in a chick leaving the nest cavity. So a lot of investment for about 50% return. Okay, so looking at provisioning, I made a total of 695 feeding observations, and almost equally split between males and females. Females brought significantly smaller prey items than males did, and there was no difference in the percentage of large items. And males are actually a little bit larger. They're heavier. They have a slightly longer bill, slightly longer wings, so they're more capable probably of bringing larger prey items than what females do. But when we looked at feeds per nestling per hour, or the feeding rate, there was no difference between males and females. They fed equally at the same rate, and it didn't matter if the young were 1 to 13 days old or 14 to 23 days old. So they pretty much share the rate of feedings almost equally between the sexes. But when we looked at fecal removals, males were much more into cleaning the nest cavity than what females were. So males did it almost over twice as often, and that value was highly significant. So one of the things I wanted to point out, and this is the case with most woodpeckers, is that males actually do kind of an let's say they contribute more to the nesting attempt than what females do when you look at the whole thing in its entirety. So it's believed that females ultimately select the site of the nest cavity, but males do most of the excavating. Males share incubation duties with the females, and the males incubate the eggs at night. The females never do. So she roosts in a separate cavity at night while the male stays in the cavity with the eggs. They share brooding duties. So when the chicks are too small to thermoregulate themselves, they have to be brooded during the day and at night. So males share that duty during the day, but they take on that activity completely at night, and they do more of the fecal materials. So males have a huge investment in the nesting period compared to other species like the American robin or a song sparrow, where the female builds the nest, the female incubates the eggs, and the male pretty much only shares in feeding the young. So a lot of male parental investment with woodpeckers. So woodpeckers make great dads. I just have to put that out there. Okay, so of the 695 observations, we were only able to identify the type of prey delivered at just about half of those. So you can imagine sometimes it'd be pretty hard to see what these birds are actually carrying in their bill, especially when they have just kind of like a whole wad or a bolus of insects. But you can see from this table here that the three most abundant categories of prey they were bringing back are wood borer larvae, which are beetle larvae where the adult beetles lay their eggs in already dead trees, and the larvae feed on the dead wood within those snags for anywhere from 1 to 3 years. And they get really large. They can almost be as long as a woodpecker's beak. So these were selected for by white-headeds primarily only during the nesting season. And if you think about it, it's kind of like giving one of these to a woodpecker is kind of like giving your kid 2 cheeseburgers. I mean, they're just loaded with fat, loaded with nutrients. So you can see why the birds are selecting these. Caterpillars were also highly chosen by these birds, and they're primarily gleaning those off of conifers. And then we have ants, which are ubiquitous in the environment. So those 3 categories made up just about 60% of what they were bringing back to the nestlings. And there were a few kind of oddballs here and there, like an antlion, a bumblebee, a crane fly, earwig, things like that. So we were able to calculate what they call a niche breadth, trying to look at how diverse their diet is. So a value of 0 would be no diversity in their prey, and a value of 1 would be a high diversity in their prey. So you can see their niche breadth was pretty low because they're primarily concentrating on these 3 main categories of insect prey. So here's a male woodpecker. This is actually one of my colleagues. She was doing a telemetry study, and you can just barely see the radio transmitter sticking down off the back of that bird. You can kind of see the wire going down. That bird there, that male, was bringing back one of those wood boring beetle larvae to the nest cavity. You can see it completely fills his entire beak. These are in the group Cerambycidae and Buprestidae. They're often referred to as the longhorn beetles or the jewel beetles. And one of the ways these birds were finding these, which was actually quite interesting, and I'm not advocating for cut stumps in any way, but they would find the wood boring beetle holes that the larvae make, and the larvae kind of push out frass, which I think is their fecal material, as they're feeding on the dead wood. And so the whiteheadeds would focus in on these little frass piles. They would find them on the surface of the cut stumps, and they would start digging and pulling out that frass to access the beetle grub in the hole. And how they get them out of the wood is not actually by excavating them out or enlarging the hole. They might do that a little bit, but once they get the frass and everything cleaned out, they use their beak in a motion like a sewing machine going in and out of the wood. And when they're doing that, they're sticking their long barbed tipped tongue down into the tunnel that the grub has made, and they wedge their tongue between the grub and the wood, and the reverse barbs on the tip of the tongue help to work that beetle grub out of the wood. So they don't actually spear it with their tongue. They just use the barbs to help work the grub closer to the tip of their bill, and then when they can grab it with their bill, they pull the grub out of the wood. So it's actually a pretty interesting process to watch them work at getting these grubs out. But it was amazing. You could watch these birds foraging, and they would land on a tree, and you could visibly see them scanning the ground in these recently harvested timber stands, looking for these stumps with the frass piles on them. For caterpillars, they were gleaning primarily spruce budworm, and this happened where the birds were occupying mixed conifer forest, where there was also pine and Douglas fir together. And you can see this female here was bringing back just a whole wad of spruce budworm larvae in her bill. And the ants included a lot of thatching ants, actually carpenter ants that they would fly catch for, and also some of the more smaller black Formica ants. So with that, I'll conclude. Thank my technicians who helped me over the years, Bureau of Indian Affairs for the funding, and then DNR, Western Pacific Timber, U.S. Forest Service, and some private landowners were able to give me access to their lands to do this study. And with that, I'll take any questions.